Let's revisit our familiar example of height measured in centimeters. Here you see the raw data for our 8 students. In this video, we will calculate the empirical variance and the empirical standard deviation. Feel free to pause the video now and give it a go yourself. Because variance is the average of the squared deviations from the mean, our first step is to recall the mean. In a previous video, we found that the mean height x bar is 168.5 centimeters. To organize our work, set up a table with 3 columns. In the first column, list your data values labeled xi. So x1 is 169, x2 is 175, and so on through to x8, which is 173. Next, for each value, subtract the mean and write the result in the second column. For example, 169 minus 168.5 equals 0.5. 175 minus 168.5 equals 6.5. 156 minus 168.5 equals minus 12.5. And so on down to your last data point. In the third column, square each of those deviations. That means 0.5 squared equals 0.25. 6.5 squared equals 42.25, and so forth for every entry. Once you have squared all the deviations, sum the values in the third column. In this example, the total is 328. Now we have everything we need to compute the empirical variance. The empirical variance s squared equals 1 divided by n minus 1 multiplied by the sum from I equals 1 to n of the squared deviations between xi and x bar. Here our sample size n is 8, so n minus 1 is 7. Putting in the numbers, s squared equals 1 divided by 7 times 328, which gives us approximately 46.86. Because variance is expressed in the original unit squared, our result is 46.86 centimeters squared. Finally, to find the empirical standard deviation, we take the square root of the empirical variance. This equals the square root of s squared. So s equals the square root of 46.86, which is about 6.85. The empirical standard deviation is therefore 6.85 centimeters, restoring the same unit as our original data.